Welcome to Talks. This is a forum that we really enjoy putting on every Tuesday that school's in session. We've had just fantastic speakers from every possible institution, and this one came in from France today, so that's kind of exciting. Realize that if you rattle your keys on the table, that'll be shared with the people out in TV land. There are people watching this today that might interact by emailing me, and I'll ask some questions to you. And there are also people that will watch it later because you've allowed us to put it on our website. And there's 100 of these talks, everything from Gordon Bell to Larry Leifer. What I want to just say is Michel Beaudouin-Lafon is a professor of computer science at University of Paris, Sud. And I can't speak French, so it's all right. But he has had, dozens of PhD students and has a tremendous influence. And he's working between LRI and INRA. These are labs in Paris, right, both of them. And is on sabbatical here at Stanford. Second year.
Second year
so
sabbatical.
2 years sabbatical. Very
this is France. We need time.
But I think modeling is always worthwhile, and I think that certainly it's very exciting to have new models that are more general and more applicable to the broad things that user experience is turning into as we go from human computer to human system interaction. And so without further ado, please, one more thing. We end about 2:25. We want to ask some questions, and then we'll have a little bit of sodas and cookies out in the hall. Okay. And I'd prefer people getting you go out in the hall because this room gets totally utilized, like 5 to 7 hours a day. So people will be coming in for other things. So go out in the hall and meet. Okay. Thank you very much.
Well, thank you, Ted. So today I'd like to talk about instrumental interaction and multi-surface environments. Before I do so, let me tell you a little bit of what we do when we're in Paris. So I work in the In-Situ Lab, which is a joint lab between university, CNRS, CNRIA, and all these complex French organizations. The lab is run by Wendy Mackay, who's even here today. And we work on a number of things. It's a fairly big group, 25 people, including 9 faculty members. We work on interaction and visualization paradigms and techniques. We explore gestural interaction as well as novel media like interactive paper and tangible interaction. We work on fundamental stuff. We are one of those groups who regularly publish on Fitts Law. And we try to explore how interaction could evolve in the future in different types of environments. We also work on mediated communication, how to help people stay in touch. We worked on media spaces a long, long time ago. And recently we've worked on projects that involve families and how to help them stay in touch. We created various prototypes, and our approach is mostly to do what we call the anti-Facebook, where the goal is not to have as many friends as possible, but to be in touch with the friends that really count for you, and to do so in a private way. We also work on design process, and especially in the participatory design approach, where we try to connect with the user populations and work with them throughout the design process. And it involves all sorts of users, such as music composers, air traffic controllers, regular family members, and so on and so forth. And finally, we build things, and we build things for building things. We build tools, toolkits, and various systems that then we try to deploy. And all these 4 themes work really one with the other in synergy. Once we've working with users, we come up with new ideas for interaction paradigms or for mediated communication systems that we then build and test in the real world. And then we try to build the tools to build the systems so they can get out of the lab. So if you're interested in coming visit us in Paris, it's not a bad city. I hear that Kai will be there in 2013. But if you can't wait, you are certainly welcome to come visit us.
Yeah, the technical chair.
And the general chair is Wendy, and I'll be the technical chair. So on with the talk. So start with the question: have you ever been frustrated when using a computer? And I'm not saying just frustrated because it crashed in the middle of you, trying to do your last line in the deadline or something. More specifically, have you been frustrated because it didn't do things that you think it should do, or that you know it does in other systems or environments or applications, but you can't use just right now because it's not there? So, for example, you're used to editing text in Word, and you know everything about how to edit the paragraph parameters of a text, but you are in, I don't know, InDesign or some other app, and it works differently, and you wish you could use the one you're used to in Word. Or have you tried to transfer information between applications that really don't let you do that, such as I'm doing slides, and I want to use the same background in my slide that I'm using in some, I don't know, a spreadsheet or some other application or in this web page. And have you ever found yourself, ended up writing the RGB components by hand on paper? And so it's striking to me that computers can do extraordinarily complex things, and sometimes for the most simple ones, they just fail miserably. And so that's one of the things that I want to get at is how do we get computers to better match the skills we have and the expectations we have in doing even the simplest things. Now, things have changed over a number of years now, but especially over the past few years, in that we use more than one device. How many of you has a smartphone, a tablet computer, a laptop, and a TV screen at home? Okay, very much everybody. Now, have you ever wished that you could use one of them to get to the other, to interact with the other? Am I stuck here at my computer to go through the slides? Can I pull out my smartphone and walk around and use it to go from one slide to the next? Well, I could if I have the right app and the right configuration, everything, of course. For those who can read, the caption on this New Yorker cartoon says, "This is so cool, I'm flying this thing completely on my Palm Pilot." And the fact that it says Palm Pilot tells you that this was done a while ago. Another example is if you're a developer, I've noticed more and more developers use a tablet next to their development machine to browse the documentation, for example. But these words are completely disconnected. They can't use the tools they have on their IDE, for example, to pull out the documentation for the method names they're typing or things like this, because those two devices are not connected. And so we're in this world where we have more and more technology, and it's getting harder and harder to make it do things together, even things that are simple. Now, why is that? Well, I think we'll blame it on the guys at Xerox PARC who created the graphical user interface. And that culminated in a way in the Xerox Star in 81, sorry. So it's 30 years ago, which started the whole personal computer revolution. And the reason I blame it on them is because they did too good a job. The GUI was just too good. And so we haven't felt really an urge in 30 years to completely change for something new, right? They designed this for executive secretaries who were dealing with memos and documents and mails and a fairly limited set of things. But they designed a solution that was general enough that we now use it for everything and anything. And this has resisted amazingly well to increase in the number of users, diversity of users, diversity of context of use, diversity of platforms, and also dealing with more and more data. And so the problem we have is that we're stuck in this paradigm of the graphical user interface, by and large, because it still works almost. If you dig a little bit deeper relative to the problems I was talking about, I think one aspect of this problem that is particularly crucial is that we're stuck in applications. And I think applications is a concept that doesn't make sense to the lay person. In fact, I gave my mother an iMac back in '98, I think. And to this day, when she has a problem, she calls me. I ask her, "What application are you in?" And she says, "What?" And for her, the concept of you have to go from application to application does not make sense. Interestingly enough, in Xerox Star, there was no notion of application. You had documents, and the document could include text and diagrams and the spreadsheets and the histograms and things like this. And you didn't have to switch from one application to the next. It was probably happening in the back somehow, but it was not exposed as a concept to the end user. But today we have desktop applications. Then we have a particular application called the browser, which is itself sort of a host of these web applications where we are reinventing the wheel. Not very well, I must say, most of the time. And then the smartphones and tablets came out, and we have apps and app stores and zillions of apps, and there's always an app for what you want to do. But the problem with apps is that they bundle together two things: knowing how to manage a certain type of data, maybe it's text or spreadsheets or musical scores or you name it, together with the interaction, the user interface to manipulate this data. So if you want to manipulate a certain type of data in a way that is not designed in that application, you're out of luck. And that's where you start juggling multiple applications and having compatibility problems and some of the problems we were mentioning before. So I think these problems of the GUI reaching its limits but still holding on, and the problem of applications sort of that's all it. And the problem of applications that are limiting our ability to freely interact in the way we want with the data we want are going to become much worse. There's been a lot of focus in recent years on getting into the small. So smartphones, maybe watches, tablets. So everybody now has these, and it will still spread even more. I think the next stage will be scaling up, going from laptops to desk size, wall size, room size, interactive surfaces. It's already happening. Tabletop interfaces have been out of the labs for a long time. In schools, you have smart boards and whiteboards, interactive whiteboards in many, many schools, in almost 100% of the schools in England, I think, and things like this. And tomorrow, the screens and displays we have here will be interactive, and it will be not just in a few meeting rooms, they will be in all the meeting rooms and also in your offices and soon after into your home. I think this is doomed to happen. When this happens, the need to fluidly interact with multiple devices, with these multiple surfaces, in a way that doesn't trap you into applications and the limited concepts of graphical user interfaces will require that we shift to something new. And I think one of the reasons why this isn't happening today is because we haven't come up with something new. You're all familiar with Mark Weiser's work in the early 90s, this vision of ubiquitous computing, of technology that disappears in the fabric of our everyday life. It hasn't happened yet, because the scenarios you see on these pictures, they don't exist today. I can't do it. I may be able to put together something like, you know, it took a dedicated person in this room to set me up with Adobe Connect and various technologies so I could do this talk. So it's still not the plug and play that we'd like it to be. Rekimoto's interaction on the right, called pick and drop, is something so obvious. How come doesn't it exist today? You know, two people are using their PDAs and they want to transfer information, and one is taking, you know, his pen, could be his finger, pick at it on his friend's computer, and then puts it on his computer. You can't do that today. And when you are in the situation, this is the first thing you want to do. So I think we need a new interaction model, probably that builds onto graphical user interfaces. There's no reason to completely get rid of it. And the tools that go with it, not just a sort of conceptual model with boxes and arrows, to reinvent user interfaces in those multi-surface environments that are already with us. So my solution to this is this: tools and instruments. So there are traces in the archaeological record that our ancestors were using tools 2.6 million years ago. It was the start of the Stone Age. Homo habilis was 2.3 million years ago, and there's evidence that he was using systematically and creating his own tools for, not so much for killing animals, but mostly for going after dead animals and peeling the skins off and the meat off and things like this. And by Homo erectus, a few hundred thousand years later, making tools was really a distinct characteristic of the human species. This image comes from an encyclopedia by Diderot and d'Alembert in the 18th century. And one of the things they did in this encyclopedia was to look at all the tools that people in the trade were using. The woodworkers and the butchers and the people making musical instruments and chairs and everything you can imagine. And what's interesting is that there are hundreds and hundreds of pages with those catalogs of instruments. And all of them are still in use today somewhere in the world. So tools are not going away. Even if you have robots, there's always a situation where you use tools. You will have a toolkit at home with screwdrivers and things like this. The reason why tools are important and useful is because they are very flexible. So if we look at this graphic designer here, he's not using a computer, and you look on his desk and you can count 10, 20 tools, from scissors to pens to this little brush, to the stapler, to various things. And if you look at how a graphic designer works with this tool, it's very fluid. He can juggle the tools in his hands. He knows, you know, he may have 20 different pens. They all look the same to you, but they're all different. And there is no difficulty in moving from one tool to the next. He can go to the store, buy a new tool. He can fix his own tools. Maybe he can make his own tools. Compare that with what I had to go through to put this slide into my presentation. You know, I had these windows and all this decorative stuff that is useless most of the time. And whenever I want to do something, it takes multiple clicks and a lot of knowledge to do something very simple. And so in the real world, we use very simple tools, a simple pen, to do extremely elaborate drawings. But on a computer, we tend to do very simple things with complicated tools. And so I think there's a mismatch here that we need to try to fix. So let me elaborate a little bit on the power of tools. And this is based on Gibson's ecological theory. So William Gibson James Gibson, sorry, William Gibson is someone else. So James Gibson was a psychologist who came up with a theory that he called ecological theory that tries to explain how we interact in the world in a way that is more holistic. It's not looking at, you know, the human visual system and understanding that. He's looking at it in a global way, hence the word ecological. And he's well known in particular for introducing the notion of affordance. And an affordance is a possibility for action that is in the environment relative to the capabilities of the subject. So affordances are relationships that only exist when I, as a subject, I'm trying to do something in an environment. So if I'm standing here and I want to go sit, a number of things in this room will afford sittability. The chairs, of course, but maybe the tables because they're not too high. Maybe the floor because it's carpeted. And this is all relative to me, to my perception of the height of these various objects, their resistance, and things like this. Capabilities I'm able to pick up immediately without doing extremely complex cognitive processing. Now, if you think of tools, the magic of tools is that once you take a tool in your hand, it redefines the affordances of the environment. Once I have a pen in my hand, things become writable. The sheet of paper, the wall, the desk, whatever. And you can test that with a young kid. It's pretty obvious. So I think the reason building on this notion of tools for creating a way to interact with computers is very appealing is because it's not something that will require basic learning of how it works. Some tools, require learning of how to use the tool, how to use it well. Think of a musical instrument or some, power tools. That's okay, because you also have tools. You know the concept of tools already. So what I did back in 2000 was to come up with this notion of instrumental interaction to describe how interaction with computers could be interpreted in terms of using tools and instruments. I use the two words for the same meaning, instead of what is usually called direct manipulation, which is the standard paradigm of graphical user interfaces that makes you think that you interact directly with your data. But you don't. You always use at least a mouse or a trackpad or something, and usually you have all these widgets on the screen. So if you want to go through a long document because it's longer than your window, you need some kind of scroll bar, for example. And a scroll bar is a good example of a tool. It's something that was invented to make things scrollable, to make parts of the document of a document that are invisible visible and controlling which parts are visible. So there's two important things here. One is every interaction becomes mediated by an instrument or by a tool. So I have this sort of thing in the middle between me and the objects I'm trying to manipulate that I call an instrument. An instrument can itself become the object of interest. If you're writing on your pencil breaks, well, your pencil becomes the object of interest and you look for a pencil sharpener to fix it. So you have this kind of construction where every interaction is mediated by an instrument. And those instruments, they are the result of an operation I call reification, where an abstract command like scrolling or like seeing parts of something that are invisible become embodied into an object that is almost physical, such as a scroll bar here. And by making this, we make the interaction going from a level that involves language and complex cognitive abilities, recognizing a command, say, scrolling in the menu, for example, or zooming, or next page, or things like this, going from the world of language to the world of physical actions where I see a scroll bar, I know I can scroll. I don't have to think. So this is a way to offload a lot of stuff and keep our brains for doing more interesting things. Finally, instruments are polymorphic. I'm sure you've all used a knife as a screwdriver one day, right? It was not designed for that. So we are, because of this notion of affordance, we are very good at inventing new uses for tools or use them in ways that were not anticipated. And that's how, in fact, we also invent new tools. But with polymorphism, I can have a tool and use it in ways that were not anticipated and use it in various contexts of use. So I don't necessarily need one tool for every single thing. Some tools will be good enough for multiple tasks. If I want to do something very carefully, I probably want the best tool for that particular task. So there's a lot of flexibility in there as well. So when I did this work, I looked at how instrumental interaction could in fact describe existing interfaces, operational GUIs, novel techniques at the times, like tool glasses here, tangible interfaces, and other things. I looked at how to compare instruments. Can we have metrics to say, well, this instrument does the same thing as this one, but is different? Not necessarily asking which is better, but how different are they? And so there are some properties I'm not going to go into here. And we built a proof of concept called CPN 2000, which was, I think, certainly the first, and as far as I know, the only tool that went out of the lab to a significant audience of more than 40,000 people, real users, that combine bimanual interaction, using two hands to manipulate things on the screen, marking menus, which are way faster than linear menus, tool glasses, which also are way faster than traditional palettes, and a number of the concepts of instrumental interaction that I just touched upon here. You had a question?
Have you read the book Software Tools by Kernighan and Plogger?
This is an old book. I wouldn't say I've read it, but I certainly, it rings a bell, and I remember in my old days, after being a student and starting a PhD, looking at these things. Yes.
Okay, I mean, there were a lot of arguments about how to actually put tools together in that era, and you're going down that same path.
Oh, you know, I'm not pretending I'm.
Yeah,
if I'm inventing something, it's the wheel. So it's. So and certainly some of the ideas behind Unix and the composability in particular, is something that was lost in graphical user interfaces, more or less, and that is very powerful in Unix. And I'm trying to get back some of this. So yes, but thank you for the reference. I think the most important thing that we came up when working on this, and the work on CPN 2000 in particular was done here with Wendy, was to come up with design principles to help people design better interfaces and better instrumental interfaces. Because time and again, and in particular when working with our users, we said, okay, what would be an instrument for doing this or that or this other thing? And after doing this a number of times, we had a number of situations of patterns that emerged, if you wish. One was this notion of reification. We want to extend the notion of what is an object. And when I reify an abstract command like scrolling or getting to things that are invisible into an object on the screen, this is an object that can be itself manipulated. So I can take maybe two scroll bars and couple them together if I want to scroll two documents together or do things like this. So by reification, I extend the power of my system. With polymorphism, the ability that for instruments to operate with as many objects as they can, which means for instruments to make as few assumptions as they can on the objects they interact with, extends the power of these instruments. So if you think of an instrument to color things, coloring can take many different meanings depending on what is the object you're coloring. And if you make your system more open to this polymorphism, you can reduce the number of instruments and do more things with them. And finally, the notion of reuse. We observed, of course, that many users prefer to reuse something they've done before and change it, even if the result is 100% different from the original, than start from scratch. And so we want to favor reusing the result of a sequence of actions, or applying that sequence of actions in a different context. And you run into well-known concepts like macros and undo, redo, and things like this, but they are in this framework that is more consistent, I would say. So a very simple example here. It's an example for aligning objects. You've all struggled with the dreadful alignment dialogue in your favorite tool. I know myself, even though I know how it works, I'll always end up with the thing piled up onto each other instead of properly aligned or distributed. And so when we thought, okay, so how can we fix this? The tool we were working with, the CPN tool here, was designed for editing these complex Petri nets. And the users were really adamant about lining things up properly, and they would spend their time aligning things. So supporting alignment was really key in that project. And we said, well, I don't want an alignment command, I want an alignment tool. Well, an alignment tool can be a guide, in red here, that is magnetic, so that when you move objects close to it, it snaps to the guide. Again, you've probably seen that in a number of tools. But then we pushed it as an instrument. So now we have this. What does it mean to move that alignment guide? Well, if I move the alignment guide, the objects aligned to it should move with it. So now what I've gained relative to this is that with the alignment command, align once, and then that's it. If I move one object, I have to realign. Here, I can decide if I move an object alone or if I move the guideline with all the objects on it. So I've gained power without really any kind of more complicated interaction. And then we can play more with that. You can have guides that are, in fact, segments. And here, the semantics is that each time you add an object to it, they get evenly distributed. So you get distribution and alignment together for free, if you wish. And you can control the distribution by moving that line or that endpoint later on to control how it is. And you can imagine circular distributions and you name it. So once you get this click from the align command to the align tool that is going to be this guideline, then without really adding much interaction, you add a lot of power to your system. So to summarize, the benefits of instruments is they decouple the data or information you deal with from the tools you use to view or edit that data or information. They are a natural way to support user customization because I can go out and pick my tools. They don't necessarily come bundled with my application and I can't change them. I should have tool stores like I have app stores today. And that means that we completely changed also the economics of the software business because instead of selling these big bundled applications, you have something that is a lot more flexible where you sell things that can edit and view some type of content, and then you can also sell tools to edit and view that content. So that's probably the biggest challenge because we're used to an economic model for software where you buy big chunks of software that do everything for a hefty price, and that forces you to buy the next version every 6 months, where here, you are much more in control of what you buy and how you buy it. So one of our guinea pigs when we deal with instruments is the color picker. Every applications pretty much has their own color picker. I found at least those online. The one I like the most is the last one here because it's in fact a tool you hold in your hand and you can go pick colors in the real world like this. But of course, each of these just works in the context of its own application. And if I want to use this one with that application or this one with that application, I can't. And so the next idea that came up is, until then we were thinking about instruments as a way to organize what today we call an application. The next step was to rip the instruments out of the application. And that's when the concept of ubiquitous instrumental interaction came up, where we created these prototypes where on a smartphone here, I think it's an N90, a Nokia, you have a color palette and you can pick a color and then use it to draw on the smartboard. Now these two computers don't really know each other very much. I could replace this with another type of system for selecting colors. Here we have a game where the system only knows about moving pieces on this grid, and we can share the grid, and every user can have their own tool for moving pieces around. So we introduced this notion of multi-surface interaction, and shortly after we pushed this one step further with the notion of interactive rooms. And so here is our wild room in Paris, where we have this very high resolution, very large wall display, 30-inch screens, so 130 million pixels on there. You have to see it to believe it. A motion capture system, 16 computer cluster there to manage the display, and an interactive table. We want to use regular laptops as well, use smartphones and tablets as a way to interact with the content. And the point here is that we want to focus on interaction. A lot of people who work on these large screens, they focus on the rendering and how fast it is and things like this. We want to focus on how you interact with it. And we know that others will take care of the nasty problems of performance and other things. And when we work on this project, even though we wanted to explore instrumental interaction, what we did first was to work with our users who are scientists from our campus in astrophysics, in chemistry, in biology, and neuroanatomy, etc., who need to really deal with big data. And we wanted to see how they would imagine interacting with this environment. So we create a number of prototypes, and we did some prototyping sessions. Here it's going to be us prototyping for ourselves. And the way we do this oftentimes is in a Wizard of Oz way. So here I have this very fancy device here, which is a piece of cardboard. And someone in the back is looking what I'm doing and scrolling the window in sync to see what it's like. Then we tried with 2D pan and zoom. So I ran Google Earth on my iPhone, and it was running on the wall as well. And the person in the back was sort of trying to sync the motions. And what became obvious is that this kind of pinch didn't work in that environment. If you were able to track the position of your device, then this physical motion was a lot more intuitive to use, because you can zoom back and forth, you can pan, so your device is sort of the camera that controls what's on the screen. And these are things that you have to try them out to really figure out what works and what doesn't. We revisited the pick and drop I talked about before here with the shovel. So you shovel something from the table onto your handheld device, and then you go to another surface, maybe the wall here, and then you can throw your thing on the wall and then maybe interact with it. The reason we do a number of these things is because the wall itself is not touch sensitive, so we have to interact at a distance. The net result of this is that we created this prototype where we can actually, on this large wall display and this table, lay out content such as these images. I'm going to have to speed this a little bit. So here we see that once the content is on the wall, it can be dragged. We use our smartphones as laser pointers to control the cursor, and we have a small interface on the smartphone to move or rescale or do some operations on the pointed content. We can send content to the wall through email. The wall has an email address, so we found this was the easiest way to send content to the wall. So every time the wall receives a message, if there's an attachment, it will be just displayed and thrown on there. We can also view live applications. So here, first, we show a snapshot of a web page that is sent to the wall. And I think in the next little segment, I'm sorry, I realize I'm. So here is a live application that is put on the table. From the table, it will be slid onto the wall again. And as James here on the right interacts with the application on the web, it's reflected immediately on the wall. And the final segment here is our fake physicist here, Fanis, who's using an AutoPen to write formulas on paper. And then as he docks the pen, or he annotates the drawing as well. And then he's going to dock the pen because this one is not a Bluetooth one. And then the content again is transferred. And so this is the type of environment where to make this work beyond a prototype, but an application that works, we need a lot of software that is designed specifically for this, not only to run our applications, but also to run existing applications. Because those scientists, they have complex visualization applications that they want to keep using on the wall. And so here's an example where we use this plastic brain here. Its position in space is tracked by our tracking system. This stick here plays the role of the camera. And the system tracks this in parallel, in real time, and controls the orientation of the 64 brain scans that are displayed in parallel on the brain. They probably all look very similar to you, but they're all different. And this is something that neuroanatomists really need to do, is to look at 64 or up to 500 brains in parallel to study differences and similarities visually, and to see if the computer tools they have are performing as well as their human experts. So this is a type of approach where they came up with this way of interacting. It's typically an instrument. It's an instrument to control a 3D view. Here, if I replace the brain with another object, I could apply it to other types of environment, other types of data. And in fact, there's another application where we have reused this instrument unmodified to interact with the protein viewer, for example. So to summarize, instruments give us a way to really look at interaction in a more general way that GUIs have had us look at it for 30 years. What I've shown in this talk is still not complete, because when we show this multi-surface environment, our wild room, to users, when they come to work with it, they always, always, always ask us, how can I work with my colleague who is at Stanford or in Germany or at CMU in Pittsburgh, or how, if you're here and you want to work with your colleagues in Pittsburgh, how would you do it? And so they want to support collaboration and remote collaboration on top of everything else. And so we just started a new project where we're creating 9 of these rooms in the Paris area, interconnected together, so the kind of scenarios that you saw in the video will be able to run with people at a distance and not only all in the same room. This is a project that's open to external partners, and if you are interested in adding a node to our Digiscope network, we'll be certainly happy to talk about it. So, instrumental interaction can get us out of the tar pit of applications to look at interaction in a more open, flexible, fluid way. Multi-surface interaction can help us realize the vision of Ubicomp, of this environment sort of becoming part of our everyday life, because interaction is fluid and simple. And they both have sound conceptual models that can be used to create software frameworks. And in fact, we've done that at the scale of what we can do in the lab as proof of concept. But the next step is really to scale this up to look not only at what's happening on the instrument side, but also on the things you manipulate, the information and the data you manipulate. I call it substrates. Explore how you can build instruments that are really, that really know as little as possible about the objects they interact with, so you can create things that are unexpected. You can also break things. I think in real life it's important to be able to break things every once in a while to see how they work. Build a robust and scalable distributed infrastructure so it runs on collections of devices, and test in various settings, especially remote collaboration. I hope we have time for a few questions, and I want to thank you.
So many of these hyperwall kind of things, we wonder if what we're going to do with all those pixels. And I was just delighted to see that the 512 brains actually were valued by the doctors. And the ones I think of are contiguous things like this Earth, where there's a mind map that matters and makes sense. Can you think of, are there dimensions to what huge amounts of visual data can constructively be used for that you can think of?
Well, at first we thought that it was really cool for large images. And so we went to the astronomers. Now the astronomers, they have images of the skies today that are 400,000 pixels wide. Our wall is 20,000 pixels. So you still need to zoom in and out by a factor of 20 to get the whole story. But we also have images, these gigapixel images. We have one of Paris that is 29, I think, gigapixel. You can zoom in up to, seeing what people are eating in their kitchen. But this is not the main use for this thing. And what we found, and it's true with scientists, and I'm sure it will be true in other areas, is the ability to put together heterogeneous data about the same phenomenon. So when we work with the biochemists and biologists, they want to look at the 3D molecule, but they also want to look at all the papers that were published about this. They want to look at sort of the DNA, the model of the DNA. They want to look at the various data in various formats and put it all together. Archaeologists, for example, in Bordeaux, another site in France, they created this room where they now run workshops where all the specialists of a particular site come in, bring their data, and they have this huge map on the wall where they put all the data they have. And again, it's about compiling data from multiple sources. Other example application is in crisis situations. Think, Fukushima or something like this, where you need to compile information from multiple sources. And in that case, the distributed aspect is even more crucial. So I think that's where the value of these large surfaces is. It's not to have a huge image of whatever it is. It's really to have more space to look at things from different perspectives.
Sometimes the easiest way for an expert to do something is different from the easiest way for a beginner to do something. And I was wondering if you have any thoughts about how you would design instruments to make it so it could work for both type of users.
Yes. And I think the answer is deceptively simple. It's the same as in the real world, is that if you're a beginner, you buy something that is simple, that is not sophisticated, that is not expensive. So think of the color picker, very simple example. But if you're a 4-year-old, the crayons are a very nice example. I mean, interface. You pick a crayon and you go draw with it. If you are a graphic designer, you want more control. You want to look at the exact RGB or different color models to compose your color, and you want palettes of colors and things like this. Maybe if you're not the type of user, you want this device and go pick the color with a real device in the real world. So go into any hardware store or art store and look at the range of tools you have for even very simple tasks. I see the same thing being possible here because there's no applications. You have things that deal with the data, things that deal with the interaction, and those are the instruments. And you can unplug one, plug another one in. Now, there is a notion of how you build up skills, and I think you will have instruments that are better at supporting learning than others. You'll have ranges of instruments. You'll have all the things we have, I think, in the real world today. Another example is think of how hard it is to learn playing a musical instrument. Developing skill. The same thing here. You should be able to develop skill and reuse that skill from one context to another. So once I've learned to use a particular instrument for a particular task, if I change what I'm working with, I should be able to reuse my instrument. I think here and here.
So, just following up on the color picker, that one, the question that brings up in my mind is the whole interface specification issue. And if you're going to get to a world where you have simple color pickers and complex color pickers and they all work with any application, the only problem you're left with is getting every application developer in the world that develops for every operating system in the world, every GUI in the world, to agree on the interface. And so if you have any thoughts about how to address that problem?
Well, I would say it is a challenge because it is tempting to say, oh, my color is not the same as yours. But, when you go down to it, there are a very limited set of basic, I would say, data types that you deal with. So with some of the prototypes we've built, the way we look at this is we say, okay, we define the API, if you wish, for an instrument in what we call a protocol. And it has several sort of layers. So there's the idle case. I am looking for something that has the method that has the right name. It's called set color, or an interface that has the right name. And I know, I can plug in right there. But if I don't find that, I can, be less picky, so to speak, and say, well, is there something that has color in its name? Is there a data field that is of type color? And if the applications are designed to be fairly resilient to this type of things, and we know how to do this because if you look at web browsers are very resilient to the type of HTML they consume, right? So if we're a bit resilient, we can make it so you can try a tool and try to make it work. And it's like when you have this, the wrong screwdriver for the screw you have. Well, you may end up breaking the thing, but that's a thing, sort of the price to pay for being able to do things that were not designed in advance. So I don't have probably the answer you expect to this. I don't want the answer to be let's go to standardization bodies and things like this. If things go well, maybe some of this would happen. I still want to maintain the ability for things to be worked out in ways that were not anticipated and have this level of flexibility that I was sort of alluding to. Yeah?
Have you come up with any sort of framework for universal mediation of interloping instruments, especially tangible instruments?
Interloping?
So from outside the environment, moving through the environment, not necessarily considered when you create these rooms?
I am not sure at well.
So the tools that I bring with me,
yeah,
and how their polymorphism transition may happen once I walk into that environment, and the awareness of the capability of the room to my tool and my tool to the room.
Yeah. One part I skipped in the talk was showing one of our architectures and how we do things, and it's based on the idea that you share a scene graph, so your content, if you wish, among, on the one hand, the computers that do the display for the wall. And the way they do this is they add what we call a facet that knows how to take this content and turn it into pixels on the screen. We have content providers, and we can have many of them, taking input from the web or from other documents or other sources, whatever. Again, what they do is they use what we call a facet to change the content. And I'm getting more to your point. These are instruments. And so instruments are here really separated from the rest. In fact, you can have them come to life and disappear dynamically. So when I come into the room with my iPhone and I launch my app, it looks at what's around, and based on that, it will offer the instruments that know how to do something with what's out there. Does this sort of answer?
Well, it's a whole
interoperability.
And yeah, and to a degree, and I've worked on this stuff for a few decades. The issue of the capabilities that come with it and how that changes in the different settings is your very premise. So I may have tools that I use, but they can change. The room changes by me bringing that tool in, but also my tool may change in what its value at the moment is to me, what its affordances are. But the problem is I've yet to see beyond demo any sort of framework that really, the resiliency you were talking about with the code, anything that comes close to dealing with that with the actual instruments we touch.
Right. Well, the prototypes we've built are, of course, not industry strength, though.
Yeah.
But we're playing with the concepts there,
where you're
and the notion is through. So this is described in a paper that was published at the last CHI conference. It's an infrastructure called Substance, and the way it works is that it has this discovery. You can have new things come into life and disappear, and it is designed to be resilient to that. So that's the idea, and that's really what we want to do. Is that there is a number of things on the wall. Someone comes in with their laptop, they're bringing some new thing, and they should be able to sort of merge it. And we have scenarios where this actually works.
It's probably important to point out that things like the brain that was a user who literally brought his brain to we had an MRI scan and he did a 3D printer thing and it was his brain. And he was the one who was saying, well, I would like to be able to do that. And then so we just added it in. And the interactive paper stuff with the Pen, we already had an independent project working on that. We said, okay, well, how do we add that in and do? So the architecture is pretty flexible in terms of being able. You didn't talk about icon.
No, we often do things live, sort of, while the users are using it. Another piece we have is this icon wild input server, where we can dynamically change the mapping between what your hardware devices sends and how it's used by application. So I can design an application in my office where I use a Wiimote, for example, as a pointing device. And then I go into the wild room, which has this fancy Vicon system. I just change the configuration in there, and the application doesn't even know what's going on or the other parts of the system. So that's what we're working on,
It's now 2:30. You know, it's this work where people build, you know, these tools that work with lots of different devices and in lots of different services. It's incredibly ambitious. It's especially exciting when somebody actually bothers to have some theory underneath it and then to try to get other places and people to use it, which you are doing all of those things. You know, the next step of things learning how to be part of that environment is also an exciting and terrifying idea. I think this is fantastic work. Thank you so much for sharing with us. Please, everyone, join us out in the hallway for some refreshments.
Thank you.
Unplug and leave. Yeah, we have a pretty good, pretty big one.